Okay, few extra proofs from lesson 5.2. Gotta adjust my headphones. So we're going to use some of those theorems that I showed you in the first video, and I want you to go ahead and put these proofs in your notebook. Okay, so you want to pause and jot everything down. Given information is circle O, and that M is the midpoint of segment AB, and we're going to try to prove that segment OM is perpendicular to segment AB. So I'm going to go ahead and put the given information in my first step. And then I'm going to try to use that if 2 points are equidistant from the endpoints of a segment, then they determine the perpendicular bisector of the segment. I think I can get two sets of perpendicular or two sets of congruent segments here. I can get this set right here because of definition of midpoint. And then this is a new trick we haven't done a lot of, but you can add auxiliary lines, or you can add lines onto a drawing if they're going to help you and make sense. So I can go ahead and put these guys in here, and I know that they're congruent because they're radii of a circle. Okay, so now I have two sets of congruent segments. So I can go ahead and so now that I know that I have two sets of congruent segments, I'm already there. So let me write out this reason. So the theorem that works for this is that if 2 points are equidistant from the endpoints of a segment, which they are, right? So these 2 points, O and M, are equidistant to A, and they are equidistant to A and B. O is equidistant to A and B, and M is equidistant to A and B. If 2 points are equidistant from the endpoints of a segment, then they determine, the perpendicular bisector of the segment. So that's how that one works, and with the cool trick of adding the lines. I have one more for you. Again, pause, write it down. One more using the theorems from this lesson. We are given that WZ is the perpendicular bisector of XY, and we're going to prove that WXY is isosceles. Let's get the information in. Given. Okay, and we can do this one in 3 steps, again knowing the theorems that we learned this lesson. So since we know perpendicular bisector, we can go right to this. And we know that because of the perpendicular bisector theorem. If a point is on the perpendicular bisector, which it is, that was given that was W is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So it's equidistant to X and Y. And in closing, I can go ahead and say WXYZ is isosceles, and that's just definition of isosceles. Definition of isosceles. We'll go like that. And we're set.